Society of Actuaries practice problems for exam FM. And this is question 11. I will read the question. A perpetuity immediate pays 100 per year. Immediately after the fifth payment, the perpetuity is exchanged for a 25-year annuity immediate that will pay X at the end of the first year. Each subsequent annual payment will be 8% greater than the preceding payment. The annual effective rate of interest is 8%. Calculate X. And we have 5 choices of answers. Next, we look at the solution. First, we have to find the value of the perpetuity immediately after the fifth payment. But because it's a perpetuity, the fact that we've gone to the fifth payment really doesn't matter because we're getting paid at the end of each year. So it's really just the present value of a perpetuity that pays 100 per year. So that is equal to a payment of 100V for the first payment. It's 100 1 year away. 100V squared for the second payment, etc. So it's 100 times the sum of V plus V squared plus V cubed off to infinity. We know the formula for that. It's 100 times 1 over I. In this case, I is 0.08. So our sum, the present value of the perpetuity, is 100 divided by 0.08. And we're going to exchange that for an annuity, so we have to set that equal to the value of the annuity. The annuity starts with payments of X, and those payments increase. The next one's 1.08X. The next one's 1.08 squared X. And there are 25 payments. So we're looking at our present value, 100 over 0.08, as being equal to XV, because the first payment's 1 year away, plus 1.08X V squared, because the payment's 2 years away. And we keep on doing this for 25 payments. The last payment will be 1.08 to the 24th X, and we multiply by V to the 25 because that payment is 25 years away. Now this is a finite geometric series. We have a formula for the sum of a finite geometric series, which would be the first term times 1 minus the common ratio to the number of terms, and that whole thing, that product, divided by 1 minus the common ratio. So the first term is xv. The common ratio is 1.08v. You can get that by looking at the second term divided by the first one. So xv times 1 minus 1.08v raised to the 25th power, and that whole thing divided by 1 minus 1.08v. However, there's a problem here. V is 1 plus I inverse, or 1.08 inverse. So 1.08V would be 1.08 times 1.08 inverse, which is 1. So the denominator of our formula in this case is 1 minus 1, which is 0. And in fact, the numerator is also 1 minus 1, which is 0. So we have a 0 over 0 coming out of our formula. This is not good. What that means is that our formula is not working. We have to go back to the summation before we use the formula. And we note that 1.08v is 1. So in those 25 terms, wherever we see a 1.08v, we're going to replace it by a 1. Now the first term doesn't have a 1.08v, so it's an xv, nothing happens. The next term does have a 1.08v in it, and we replace that part by 1, and we're left with an x and another v that hasn't been used up. So we're left with xv in the second term. The third term also has a 1.08v. In fact, it has 2 of them. And when we replace those by 1, we're left with an x and the extra v. So we're left with an xv again. So apparently we're getting xv for every single term, including the last one. And there are 25 of these. So to sum them, we just get 25xv, or 25x times 1.08 inverse. So we're going to set our present value of the annuity, 100 over 0.08, to 25xv, and we can solve for x from that. And if we do that, we get 54 as our answer, and 54 is answer A among our choices.